Honey, what's a tectonic plate?
I am glad you asked. A tectonic plate, also called a lithospheric plate, is a massive, irregularly shaped slab of solid rock that makes up the Earth's outer shell. The concept is the foundation of plate tectonics, the theory that explains how the Earth's surface is constantly moving and reshaping itself. Think of it like biscuits floating on top of a solid gravy, a asthenosphere. But the gravy is solid, but is heated so much that it moves slowly. They stay on the surface, but they bump into each other as the gravy moves underneath. This flow is driven by convection currents, heat rising from the core which carries the biscuits along with it.
So, they're just crust?
Well, not really. They are composed of the lithosphere, which includes two distinct layers. They are, 1. The crust, the outermost layer of the Earth. 2. The uppermost mantle, a rigid, solid layer of rock directly beneath the crust. These plates float on top of the asthenosphere, a deeper layer of the mantle that is hot and under so much pressure that it behaves like a very thick, malleable plastic. This ductile nature allows the rigid plates above to slide over it.
How many types of plates are there?
There are two primary types of plates. They are oceanic plates and continental plates.
Is there a difference?
Yes. The difference between the two plates are as follows. 1. Oceanic plates, primarily composed of basalt. The density is higher, meaning it sinks more easily. The thickness is approximately 5 to 10 kilometers and it is young. 2. Continental plates, primarily composed of granite. The density is lower, meaning it is more buoyant. The thickness is approximately 30 to 50 kilometers and it can be billions of years old.
Can plates interact?
Yes.
In what ways?
There are three primary ways.
Elaborate, please.
1. Transform boundaries. Plates slide past each other horizontally. The San Andreas Fault is a famous example. No new crust is created or destroyed here, but the friction causes frequent earthquakes. 2. Divergent boundaries. Plates pull apart from each other. This usually happens on the ocean floor, like the Mid-Atlantic Ridge, where magma rises to create new crust. 3. Convergent boundaries. This is divided into three outcomes. I. Oceanic and continental. The denser oceanic plate sinks, subduction, creating volcanoes and deep-sea trenches. 2. Continental and continental. Neither plate wants to sink because they are both buoyant. Instead, they crumble and fold upward to create massive mountain ranges. For example, the Himalayas mountain range. 3. Oceanic and oceanic. One sinks under the other, often forming volcanic island arcs. For example, Japan.
Why do they move?
The primary reason behind plate movement is mantle convection. Heat from the Earth's core causes molten rock in the mantle to rise, cool, and sink in a continuous cycle.
Is that the only factor?
There are two other factors that contribute to the cause of the movement of tectonic plates. Together, the three factors are: 1. Mantle convection. 2. Slab pull, the weight of a dense, subducting plate pulling the rest of the plate behind it into the mantle. 3. Ridge push, gravity sliding the cooling, thickening plate away from a mid-ocean ridge. 1. Mantle convection, think of it as the engine beneath the plates. Heat from the Earth's core causes the semi-solid mantle to move in slow, circular currents. As the mantle moves, it acts like a conveyor belt, dragging the plates along with it. 2. Slab pull, this is often considered the most powerful force. When an oceanic plate becomes old and cold, it gets denser than the mantle beneath it. As it sinks at a subduction zone, the weight of that slab pulls the rest of the massive plate down behind it. 3. Ridge push, at mid-ocean ridges, new, hot magma rises and cools to form new crust. Because this new crust is elevated and hot, gravity pushes the older, cooling plate away from the ridge crest, sliding it downhill toward the subduction zone.
If the plates are always moving, where is this restaurant going to be in 50 million years?
That will be for another video.
And, if slab pull is so strong, why hasn't the whole Pacific plate disappeared yet?
Again, for another video.
Oh look. The waitress is coming.
Sir, what can I get for you?
I would like vegan carbonara and a glass of lemonade.
Madam, what can I get for you? I would like vegan fried rice and a glass of lemongrass tea.